Okay, so my previous video somehow stopped recording, so I'm not sure exactly where I left off. So I'm just going to go through this example 2b one more time. So the cubed root of 18 times the cubed root of 6, because these are both cubed roots, you can multiply the numbers underneath, giving you 18 times 6 or 108, which can then be factored into a cubed root of 27 times a cubed root of 4. The cubed root of 27 is then becomes 3, and the cubed root of 4 cannot be simplified. The other method of simplifying this radical, and again, it kind of depends on how big your numbers are, what method you choose, but instead of multiplying the 18 and 6 together to get 108, I factored the 18 into my prime factors. So 18 can be factored into 3 times 3 times 2. And then 6 can be factored into 3 times 2. So once you look at the prime factors, you can see that there are 3 factors of 3, or 3 to the third. And then you also have your 2 times 2, which would be 2 squared, but we're not going to really be able to do anything with that. Actually, let me make that a separate, times the cubed root of 2 squared. So the cubed root of 3 to the third then will simplify to just 3. Because there are only 2 factors of 2, it cannot be simplified. So, or we can't take, it's not a perfect cube, but we can simplify the 2 squared to 4. So again, we get the same thing. It's just a matter of whether you want to multiply and then break it down, or break it down, then multiply. Okay, next example has numbers and variables now. So it's just a little bit more complicated. So you've got this -2 out front, but there's no coefficient here, so I'm going to just keep that -2 out front. And it's a fifth root. The 81 and 45, I could multiply those together and get a very large and negative number. But instead, I'm going to factor that 81 down into 3 times 3 times 3 times 3, because I know that 81 is 3 to the fourth power. So 3 times 3 times 3 times 3. The -45, I'm going to separate the -1 from the 45. And then 45 can be factored into 9 times 5, 9, which can be factored into 3 times 3 times 5 then. So the -1 times 3 times 3 times 5 would be -45. Now the variables, I'm going to go ahead and multiply them together right away. I've got a to the 7th times a to the 1st, which would be a to the 8th. Okay, so this is about as complicated as we're going to get with these problems. You've got a fifth root. So when you have a fifth root, you need a perfect fifth power. So we have 1, 2, 3, 4, 5. We also have an additional factor of 3, but we only want 5 of them. So I'm going to take those 5 factors of 3 and rewrite it as a fifth root of 3 to the fifth, because I know that the fifth root and the fifth power will reduce, giving me a nice whole number, 3. Now, the a to the 8th can also be factored into a fifth root of a to the 5th times a fifth root of a to the 3rd. So your fifth root of a to the 5th now becomes a. And then the stuff that's going to be left over, the -2 is still in front, but inside the radical, it's still a fifth root, but we still have the negative. Actually, nope. I'm going to separate that fifth root of -1, because -1 is actually a perfect fifth power. So the fifth root of -1 all by itself is -1. Now I'm going to put together what's left. So the 3 and 5 would be 15 underneath the radical. Okay, so the -2, the 3, and the -1 if I multiply those together now, would be a positive 6. The a that I got from taking the fifth root of a to the fifth would go next to the 6. And so I'm done with this. I'm done with this, I'm done with this, I'm done with this. So I've got the 15 and a to the third that are not perfect fifth powers, so they have to stay inside the radical. So the simplified answer would be 6a fifth root of 15a to the third. All right, so that's about as complicated as these are going to get at this level. The next ones are practicing multiplying some monomials and binomials together. So this first one here, you have a square root of 3 times the binomial -5 square root of 6 plus square root of 10. So if we distribute this square root of 3 to both terms, you can only multiply square roots with square roots and whole numbers with whole numbers. If you wanted to, you could put a coefficient of 1 there. So if I multiplied my coefficients, 1 times -5 would be -5. And then if I multiply the square root of 3 and the square root of 6 together, I'm going to get the square root of 18. And then if I distribute the 1 to the positive 1 basically here, I'm just going to have 1, which I don't need to write anything for that. And then the square root of 3 times the square root of 10 will be the square root of 30. At this point, you have to ask yourself, can I simplify either one of these square roots? So we're looking for perfect squares. Does 18 have a factor that's a perfect square? Yes, 9. So the square root of 18 can be factored into the square root of 9 and the square root of 2. The square root of 9 then becomes 3 times the -5 that's out front is -15 square root of 2. If you think of your factors of 30, the only factor of 30 that's a perfect square is 1, which will not help us simplify this. So the square root of 30 is just brought down. And you cannot add these because these are not the same radical. Even though they're both square roots, the radicand that's underneath is not the same. So this is now as simplified as we can make it. In example 3b, I'm going to multiply or distribute the square root of 5 times the -2 square root of 5. And then I'm going to have to take the square root of 5 times the -4. You will then have to distribute the -7 to both terms also. Keeping in mind you can only multiply square roots with square roots. So this square root of 5 and this -2 square root of 5 would equal -2 square root of 25. Well, the square root of 5 times square root of 5, which is square root of 25, becomes 5, because that's a perfect square, which then gives you -10. If I multiply the square root of 5 times -4, I get -4 square roots of 5. That will not be simplified, cannot be simplified. All right, so now let's distribute the -7 to each term here. So the -7 times the -2 is a positive 14 square root of 5. The -7 times the -4 is a positive 28. So now if you look at your middle terms, they are like terms because they both are square roots and they both have a square root of 5. Unlike this last example, here we had a square root of 2 and a square root of 30. These are both square roots of 5, which means you can combine them by adding your middle terms together, or your coefficients, -4 and 14, if I add those together, will be positive 10 square root of 5. But I also have this 28 to bring down. And 28 is now a like term with -10. So I can combine those constants together. And -10 plus 28 is 18. And then the 10 square root of 5, we cannot add these together because they are not like terms. The 18 does not have a square root of 5, but the 10 does. So 18 plus 10 square root of 5 is as simplified as we can get. All right, in our last two examples, we have a couple special product rules going on. So we have basically a sum and a difference. So I'm going to show you the long way, and then I'm going to give you the shortcut. And we actually have done this before. where we have a sum and a difference, but this is good review. So if I take the square root of 7 times the square root of 7, I get the square root of 49. I'll simplify that in a second. The square root of 7 times my negative 3 will be negative 3 square root of 7. The 3 times the square root of 7, it's positive, so positive 3 square root of 7. And positive 3 times negative 3 is negative 9. When I simplify the square root of 7 now, I get 7. The negative 3 square root of 7 and the positive 3 square root of 7 basically cancel each other out, which gives me 0 square roots of 7, which I don't need to even write down in my answer, and then minus 9. So I don't really need that 0. So 7 plus negative 9 then will be negative 2. All right, so in the last unit, we used the product rule that said a plus b times a minus b would equal a squared minus b squared, which basically means you take the first term in each binomial and square it minus the second term in each binomial squared. So if I look at what I originally had, I had square root of 7. So if I were to take the square root of 7 and square it minus my second term in the binomial, which was 3, and square that, I would have gotten 7 because the square root and square cancel each other out, but the 3 squared would be 9. 7 minus 9 is negative 2. So using that special product rule, I would have gotten to the negative 2 just a little bit faster. Okay, let me zoom out here a little bit so you can see that better. The next problem is another special product rule, but it's a binomial squared. So one way of squaring a binomial is by rewriting it times itself. So when I multiply it by itself, now I can distribute the 3 square root of 2 times another 3 square root of 2, which will be 9 square root of 4. The 3 square root of 2 times 11 would be 33 square roots of 2. Then take your 11 times 3 square root of 2 and get another positive 33 square root of 2. Then take your 11 times your 11 and get 121. When you simplify the first term, the square root of 4 becomes 2 times that 9 will be 18. When you combine your middle terms, since they're both square roots of 2, you can add the coefficients, which will be 66 square roots of 2. Bring down the 121 and now combine the 18 and the 121, which will give you 139. Yeah, plus 66 square root of 2. All right, so that's one way of squaring that binomial. The other is, again, using that special product rule that says if you have a binomial squared, now let me rewrite it down here. So a plus b squared equals the trinomial a squared plus 2ab plus b squared. So in my binomial, 3 square root of 2 plus 11 that I'm squaring, the a is basically your 3 square root of 2. So if I take that 3 square root of 2 and square it, I'll simplify that in a minute, plus 2 times a times b plus b squared. So a is 3 square root of 2, and then b is the 11. And then again, I'm going to put the 11 here. Now simplify. So when you are squaring the 3 square root of 2, make sure that you square, zoom in just a little bit, make sure you square both the 3 and the square root of 2. So 3 squared would be 9, square root of 2 squared would be 2, which simplifies to 18. In your middle term, multiply the 2, the 3, and the 11 together, which will give you that positive 66. And then square root of 2 is still in the radical. And then your 11 squared is 121. Again, you have like terms of 18 and 121. again equaling 139 plus 66 square root of 2. So there's a couple different ways you can work that problem out. Whichever is more comfortable to you is fine with me.